Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for the GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide, the 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 282. Page 282, and today is our lesson number 108. The problem that we are about to solve is number 84. Let's take a look at it. Turn to page 282. Read the problem to yourself. Number 84. The question simply is, what's the value of n in the list that they're giving us? What is n in the list? And here's the list: k, n, 12, 6, and 17. Let's see what they give us in the first statement. In the first statement they tell us that k is less than n. Is that enough for us to figure out what n is? The answer is no. The answer is no, this is not enough. Now don't worry about the fact that sometimes I use the capital letter, sometimes I use a small letter, it doesn't really matter. The first statement is not enough. Therefore, A, D, B, C, E. Let's erase this part from the previous problem so we don't get confused. Since the first statement by itself is not enough, the answer cannot be A, nor can it be D. Let's look at second statement. The second statement tells us that the median is 10. Since they are talking about median, it will be wise for us to arrange these numbers in order. But before we do that, since the median is 10, we have 6 and the median is 10, which means one of these numbers has to be 10. This implies that either k is 10 or n is 10. In other words, our list will look like this. The smallest number is 6. Then we'll have our 10, which is either k or n. And then we'll have our 12. Oh, median is 10. 12 falls in the middle. Something has gone wrong. Oh, then we'll have our median is 10. So let me start again. Median is 10, it's going to fall in the middle. If k equals 10, then n will go here, and this will be our 6, and that will be our 12, and what else do we have? And 17. So that's one possible list. On the other hand, if median happens to be n, then this must be k. The one before must be k, because all the others are fixed. We have a 6, we have a 12, and we have a 17, and since there are 5 numbers, the median has to be the middle number. So the question now is, which one is it? Is this the scenario we're dealing with, where k happens to be 10, or is this the scenario we're dealing with, where n happens to be 10? And since they're asking us the question is, what is the value of n here? We do not know. If it happens to be 10, then all we can tell is that n is something less than 10. It could be anything less than that, any number at all. There are infinite possibilities. On the other hand, n could be the one that is 10, in which case n is the median. We cannot tell which scenario we're dealing with. The second statement by itself is also not enough. Therefore, the answer cannot be B. Let's put them together. When we put the two statements together, now we know for a fact that k has to be less than n. K has to be less than that. That tells us that we are dealing with this scenario. We are dealing with the second scenario. We are dealing with the bottom scenario right here. And if k is less than 10, if k is some number less than 10, and we know the median is 10, then n would have to be 10, because 10 is missing from the list. So the list that we end up with is 6, and then the k, and that's our n, which is equals to 10, and then the 12, and then the 17. Voila. The median is 10, and that must be n, because k is less than n, therefore k has to come to the left of n. That's all. The answer is C, because putting them together, putting the two statements together does the job. Putting the two statements together, we are able to tell what n is. N must be 10. That's all. Let's do the next one, shall we? Problem number 85. Let's take a look at it. Problem number 85. I'll give you a second actually to do whatever it is that you want to do with it. Problem 85, they tell us x and y are integers. X and y are integers. The question simply is, how much is x plus y? This is a very silly question, this is a very simple question, it's a very babyish question. In the first statement they tell us that 3 is less than x plus y over 2, which in fact is less than, which in turn is less than 4. If you multiply the entire inequality by 2, and since 2 is a positive number, we can do that without having to worry about switching the direction of the inequality. If you multiply the entire inequality by 2, this 2 drops out, and we end up here at 2 times 3, which is 6, which is less than x plus y, which we are told is less than 8. And since both x and y, since they are both integers, since both x and y are integers, they are whole numbers, therefore their sum must be 7. Because we know now that their sum has to fall somewhere between 6 and 8. So we know the sum of the x and y is somewhere between 6 and 8, and we also know that their sum has to be a whole number. Well, if it has to be a whole number and it falls between 6 and 8, there's only one possibility, it must be 7. Which is what, even though we do not know the individual value of x and y, it's okay, because we're not interested in looking at we're not interested in what their individual values are. The question simply is, what is their sum? And to which the answer is 7. So the first statement does the job. A, D, B, C, E. Since the first statement by itself works, answer cannot be B, C, or E. It would have to be either A or a D. Okay? We are not interested in figuring out the individual value. You're right. If they were asking us what is x and what is y, to which the answer would be, there is no way to figure it out. But we are not looking for their individual values. We are only interested in their sum. The question is, what is their sum? Let's look at second statement. In the second statement, they tell us that 2 is less than x, which in turn is less than y, which in turn is less than 5. Again, since x and y are integers, since x and y are integers, they are whole numbers, therefore, and because of the fact that they have to fall between 2 and 5, x is more than 2 but less than y. If this is 2, this would have to be 3 because they are whole numbers. 2, 3, 4 and 5. Voila, that's it. In this case actually we are able to figure out the exact value of x and y. This actually is, the second statement actually is more powerful than the first statement, because this actually enables us to pinpoint the exact value of x and y individually. X must be 3 and y must be 4. Y would have to be 4. Why? Because of two conditions that we have to fulfill. The first condition the y has to fulfill is that y has to be more than x, and y has to be a whole number. Well, if y has to be more than x, then x has to be more than 2, and x has to be a whole number, and they have to fall between 2 and 5. Well, there are only two whole numbers between 2 and 5, 3 and 4. Therefore, one would have to be 3 and the other one would have to be 4. That's it. And therefore, we can answer the question. The question was, what's the value of x plus y? And the answer is 7, just like before. Except here, we know the individual value. And because two of them together, because the second statement by itself also works, the answer is D. See, that's why I have this habit of doing this thing. And every single data sufficiency problem, as I finish analyzing one statement, I write down A, D, B, C, E. Precisely for this reason, what just happened a second ago, I was almost about to pick C. But I would not have chosen C because C is already crossed out. After all the work, for a brief split second, I lost train of my thoughts, I lost my concentration, and I was about to pick C instead of D. But C is already crossed out. It has to be either A or a D. And of course it's D because second statement by itself also works by individually, independently. That was the end of it. I will see you tomorrow, okay? Bye now.